Welcome back, my students, to the last lesson in halogens is chlorine. How we can prepare chlorine in the lab. As we see here, we have the flask, benzene burner, valve bottles, receiver container, and delivering tubes. Also, we have some chemicals such as hydrochloric acid and manganese dioxide. We have to put the manganese dioxide in the flask, then we have to put the hydrochloric acid. By heating manganese dioxide with hydrochloric acid, they react, producing manganese dichloride, water, and chlorine. Chlorine mixed with some impurities such as hydrogen chloride. That's why it's passed through water. Why? To remove the impurities of hydrogen chloride. But now chlorine carries some drops of water. That's why it passed again through concentrated sulfuric acid to absorb the drop of waters and make it dry. Then the pure, dry chlorine is received in this container. The equation is hydrochloric acid plus manganese dioxide give us manganese to chloride, water, and chlorine. So here we have to put manganese dioxide, then we have to put hydrochloric acid, and in this container we have water to absorb the impurities such as hydrogen chloride. Then we have to pass it through concentrated sulfuric acid to make it dry. Then we have to receive it here. Yes, the question? During the preparations of chlorine in laboratory, it passed through water. Why? To remove impurities of hydrogen chloride gas. Then it passed through concentrated sulfuric acid, H2SO4. Why? To dry it by absorbing water. Chlorine is prepared in lab inside a fume cupboard or chamber. Why? Because it's a poisonous gas. So this is about the preparing in the lab. But we have another method in industry. In industry, we have to prepare it in large amount by electrolysis of table salt. So from table salt we can get what? Chlorine and also sodium. But here we talk about the chlorine. Yes, this is the electrolysis process. Yes, this electrolytic cell. It has the cathode, which is connected with the negative terminal of the battery, and the anode, which is connected with the positive terminal. Now in this case we have NaCl. Na as a first part is positive and Cl this second part is negative. Now the positive one goes to the cathode because it's negative here, yes, and the negative goes to the anode because anode is the positive. We get at the cathode, yes, we get sodium at the cathode, and we receive what? Chlorine at the anode. And in this case, yes, we prepare chlorine by electrolysis. Electrolysis means by passing electricity. What are the physical properties of chlorine? It's a poisonous gas. That's why it's prepared in lab inside a fume covered chamber. It has a choking smell. It is heavier than air. It is a pale green gas. What about the chemical properties of chlorine? It turns moist litmus paper red. It means it has acidic effect. It bleaches the color of the cloth and removes the color of flowers. It doesn't burn or sustain burning. If a candle is put in a jar containing chlorine, it will be blown out. It dissolves in water, forming hypochlorous acid, HClO. It reacts with sodium, forming table foot salt, NaCl. Here are some reactions with metals forming salts, such as with sodium forming sodium chloride, what we call it table salt. Sodium plus chlorine give us sodium chloride. With potassium with chlorine give us potassium chloride. With calcium with chlorine give us calcium chloride. With aluminium, forming aluminium chloride. So all of these compounds are salt. With nonmetals, with phosphorus, but we have to focus here. If you have small amount of phosphorus, so it gives us BCl3. But if you have large amount of phosphorus, so it gives us BCl5. Again, chlorine reacts with small amount of phosphorus to give us, yes, BCl3. Chlorine reacts with large amount of phosphorus, give us BCl5. The last reaction with the water, chlorine dissolve in water and give us, hypochlorous acid, and also with the HCl. Thank you very much.